Alright, so we've been working with substitution, and with substitution one of the goals is to get one of the variables by itself. Okay? With elimination, you're not trying to get a variable by itself as much as you're trying to eliminate one of the variables. Okay? And it's the same process. You want to get an equation that just has one variable so you can actually find a value. Okay, the way they're set up at the moment, initially each equation has more than one variable, and you can't solve for a value at that point. So the goal for elimination is that you solve for a value. Okay. So it says, when you're solving a system using elimination, you must get one of the variables to have opposite coefficients in the equation. So, a couple of questions. DG, what's the coefficient?
Oh, no, I will be over.
I know, that's one of the problems with having right now. What's the coefficient? The number that goes in front of the variable, yes. What does it mean to have opposite coefficients? A negative and a positive, but they would need to be, for be opposites, they'd have to be the same number. So it'd be like a negative 2m and a positive 2m. Okay, those would be opposite coefficients. Okay? And so one of your variables has to have opposite coefficients for you to be able to use the process of elimination. 2, if you don't have the opposite coefficients, then you must multiply one or both equations by a constant to get opposite coefficients. Okay, and we'll talk about that here in the second example. And once you do have opposite coefficients, then step 3 comes into play. You add the two equations together to eliminate one of the variables. And the variable you will eliminate is the one that has the opposite coefficient. And so, last thing, you just substitute back in to get the other variables. So, here we go. First problem. Okay. All right. Very quickly, do these two equations have a variable with opposite coefficients?
Yeah.
Yes, which one? Hey, if you're not looking at notes or taking notes on our stuff, you just get closed up. Yeah. So since the y already has opposite coefficients, and we skip to step 3, and step 3 says you add the two equations together. And so when you add, you combine all your like terms. So 2w plus 3w is 5w. 5y plus a negative 5y is gone, eliminated. Negative 24 plus 14 is a negative 10. So once you have eliminated a variable, it's usually a pretty easy step at that point. So w equals negative 2. And I got that because I divided both sides by 5. Now, just like in substitution, once you find one variable's value, you got to plug it back in to find the other. And so we're going to take this negative 2 and plug it back into one of our original two equations and solve for w. So now I'm going to rewrite that first equation. Do the second equation, should work too, or will work also. Just plug in for w is a negative 2. Okay, so there's step by step written out. If you need help on any of those little steps, let me know and we'll get there. So what is my solution here? The ordered pair, -2, -4. Yeah, if you've already got the opposite coefficients, this method is very easy. Okay? Now, sometimes you end up with the fraction as one of your answers, and if it's the first one you find, then that makes it not quite as easy, but it's still not too difficult, especially with the use of calculators. All right, questions on that one? Can I move on to the next one?
Yeah.
Okay, here's the second problem. Okay, do I have opposite coefficients on either of my variables? No. Okay, so the way to get that now is step 2 says you need to multiply either one or both equations by a constant. A constant is just a number to get opposite coefficients. So the easiest one, we'll talk about both that. If I want to get m to be opposite, I'd have to multiply the top equation by 5, that would give me 10m, and the bottom equation by 2, which would give me -10m. But that's multiplying both equations. It's actually easier, as Marissa just pointed out, if you multiply the second equation by -3. Then I don't have to multiply the top equation by anything because I would have a positive 3n and a negative 3n. Okay? So I'm going to multiply equation 2 by a -3. Okay, and then you distribute that -3 to the entire equation. So 15m minus 3n equals 39. Now that's the equation you're going to now add to the first equation.
That one equal out.
Do what now?
It changes to a subtraction.
Okay, so now add that first and that third one. So 2m plus 15m is 17m. 3n plus a -3n cancels out.
Oh, that's
12 plus 39 equals 51.
okay, my bad. I see what
Okay. Last step. Divide by 17, you get m equals 3. 51 divided by 17 is 3. Alright. So once you get that, you need to plug something back in. Now I need to solve for n. So I'm going to go back to my original second equation because n's already by itself. And that's where I'll plug the 3 in. I'm going to plug the 3 in for m right there. And so it'll be -5 times 3 plus n equals -13. So I just need to add the 15 to both sides.
do we have to put it into that one?
And I get n equals 2. No, you can plug it into the first one. It's fine. I wouldn't plug it into the 15m one because the numbers just get bigger. There's no reason to do that. But either one of the first two equations is fine.
I was making sure. I plugged it in. We got the same thing.
Okay.
Making sure.
All right. Now, last period, the question came up of, does it matter which order you put the answer in? Can you put 3-2 or 2-3? It does matter. It always matters because M equals 1 and N equals 1. A specific number, not the number 1, but a specific number. But somebody I heard say it, it's always alphabetical order. So M comes before N, so it'll be 3, 2. Okay. These are always in alphabetical order. Okay. Questions? All right.